Welcome to the first phase of the engineering design cycle, identifying the problem. In many situations, identifying the problem may be partially or completely done already, but in other cases, especially in classroom situations, design problems may be far more open-ended, allowing the engineer or the student to look at a variety of problems at the start. Regardless, at this phase of the design cycle, no design should go forward without first clearly identifying a problem that needs to be solved and verifying that it makes sense to solve it. The first step in identifying the problem in engineering design is likely to be some form of brainstorming, in full or in part about the design itself. This is the time to explore a wide space of ideas and identify who may need what and why. Now is the time to explore ideas from the incremental to the boring to the wild and crazy, and to take full advantage of the capacity of the human mind to be creative and to think both inside and outside of the box. At its most creative, brainstorming is often best done alone, so that group pressures or team dynamics do not suppress what could potentially be a winning idea. Brainstorming alone seems contrary to the way that most engineering is done, as a team. However, to best leverage the talents of many different individuals, research by Google and other large companies has shown that working alone at first is the best way to capitalize on creative energy and individual talent. With that in mind, let's take a brief journey through the world of brainstorming as we strive to identify a problem worth carrying through the full journey of the engineering design cycle. It's easy to think that brainstorming is a random process by which ideas come forth from an unpredictable human brain. Contrary to the misconception that brainstorming is a random walk through a random hat in the creative brain, brainstorming can and should be as methodical as any other part of engineering. At the beginning of brainstorming, it is important to define the context of the brainstorming session. Here, during the very start of the engineering design cycle, we should strive to identify problems and avoid thinking about or spending time on solutions. Considering solutions may thwart the creative process or cause ideas to be discarded even before they are considered by the design team. Golden opportunities may be missed by jumping into solutions too soon. So at the beginning, alone in our own heads, it's important to list problems consistent with the design focus, but problems only. No solutions allowed just yet. After we have defined the context of our brainstorming session, in this case to identify problems and to avoid considering solutions, the next step is simply to state the goal of brainstorming, preferably on a sheet of paper or a post-it note that will remind us of the goal throughout the brainstorming phase. For example, here is a goal that is consistent with a design course in sensors: to identify sensing systems that meet a significant need in society and which can be designed, prototyped, tested, evaluated, and presented during a single term. Once a goal such as this one is articulated and in written form, it's now time to move on to the actual generation of ideas. Whether using a computer or paper, brainstorming is often best done using a nonlinear way of recording ideas. No bullet or numbered lists at this point. Rather, the ability to move post-it notes around on a table or other ideas around on a screen in whatever way we wish, and then to rearrange them over and over again, is ideal for this phase of brainstorming. Because post-it notes can be moved around on a board or table and organized later, an individual who's brainstorming can write down anything, regardless of whether it's related to the previous or the subsequent idea, and regardless of whether the idea is boring, ridiculous, normal, wild, crazy, or otherwise. All ideas together will capitalize best on the brain's immense creativity. During initial brainstorming, strive to generate as many ideas as possible that fit within the stated goal, no matter how strange or unrealistic they may be. Challenge yourself to generate at least 20 to 25 ideas for a given brainstorming session. You never know what you'll come up with. Once the ideas are generated, they can be arranged according to theme. The themes will vary with the purpose of the engineering design activity. In this example, ideas are reorganized by themes consistent with a classroom design project, by potential use of some skills over others and pursuing some ideas over others. The 3 themes shown here are just examples of how ideas might be organized according to themes and will vary from one design problem to the next. Different students and different individuals might group their ideas according to entirely different themes, but organization is essential to being able to pare down the list of ideas to a very few that can then be brought to the design team. Next, in this brainstorming process, is to identify the priorities of the design effort. In a classroom setting, this may well be related to individual educational and career goals, as shown here in priorities 1 through 4. You may want to learn specific programming languages. You may wish to learn or strengthen certain hands-on skills. You may wish to learn more about a particular concept or theory. But in this phase of brainstorming and identifying the problem, it's simply important to understand what is important to you during the design process. Whether these priorities are met by the design team or the design itself will come later. At this stage in brainstorming during identification of the problem, the process has now become much more methodical and rigorous. At this point, we can take a look at the themes from organizing our original ideas and connect them to our priorities, looking at them side by side to see where the best match is. The result of matching themes to priorities gives us a predictable instead of a random list of our top ideas. From matching the design to the person or the designer, we may get 1 or 2 choices, but in most situations we will end up with 3 to 5 choices to take forward to the design team. And in making this process more formal, we can be assured that the ideas we take forward are likely to be ones that are important to us and also enjoyable to pursue throughout the rest of the engineering design cycle. In an open-ended design project, brainstorming is not only necessary, but fun. In a more close-ended project where the boss or the teacher or the company has already constrained the design, brainstorming may seem unnecessary and worthy of being skipped altogether. However, going through the brainstorming process at the start of every design always has value. It prevents us from confining ourselves to a particular type of solution or narrow approach that has limited potential. It keeps us from considering or reviewing why we are in the engineering design process in the first place. Are we simply trying to graduate? Are we trying to get a promotion? Are we trying to avoid crazy work hours with even crazier ideas? Are we trying to produce a wildly successful product? Exploring our priorities in combination with exploring design ideas opens our minds to a wider range of possibilities and keeps the brainstorming process exciting, intriguing, and informative as we use it to move forward in the engineering design cycle. This concludes our brief introduction to brainstorming during the Identify the Problem phase of the engineering design cycle. Thank you for joining us. We certainly hope that this introduction to brainstorming has been helpful to more thoroughly explore engineering design, and that you'll join us again as we take a detailed look at other phases of the engineering design cycle.